4-wire feeder is required from the meter disconnect to the panel. The grounding electrode conductor must be bonded to the neutral of the service entrance. The reason for this requirement is that the grounding electrode conductor provides a low impedance path for fault currents to return to the source, while the neutral conductor provides a path for normal load currents to return to the source. Bonding the grounding electrode conductor and neutral conductor of the 200 amps panel would prevent the grounding electrode conductor from effectively providing that low impedance path for fault currents. In a typical electrical system, power is delivered from the utility transformer to the customer's service entrance. The service entrance is the point where the utilities equipment connects to the customer's wiring. From the service entrance, power is distributed throughout the building to various loads. The National Electrical Code, or NEC, provides detailed guidelines for the safe and effective installation of electrical systems. Several articles within the NEC address the requirements for grounding and bonding. Grounding refers to connecting the electrical system to the earth, while bonding involves connecting various metallic parts of the electrical system together to create a low impedance path for fault currents. The purpose of grounding is to provide a safe path for fault currents to flow back to the source, which helps to protect people and equipment from electrical shock and fire hazards. Bonding ensures that all metallic parts of the electrical system are at the same electrical potential, which reduces the risk of electrical shock. The grounding electrode conductor connects the neutral conductor at the service entrance to a grounding electrode, such as a ground rod, a ground plate, or a metallic water pipe. This connection establishes a reference point for the electrical system and provides a path for fault currents to flow back to the source. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. The neutral conductor carries the unbalanced current in a 3-wire or 4-wire electrical system. In a properly grounded system, the neutral conductor is connected to the grounding electrode conductor at the service entrance. This connection ensures that the neutral conductor is at or near ground potential. Bonding jumpers are used to connect various metallic parts of the electrical system together, such as metal conduits, metal enclosures, and equipment grounding terminals. These bonding jumpers create a low impedance path for fault currents, which helps to protect people and equipment from electrical shock. The size of the bonding jumpers is determined by the size of the circuit conductors, as specified in NEC Table 250.102. The equipment grounding conductor, or EC, is a dedicated grounding conductor that runs along with the circuit conductors to provide a low impedance path for fault currents back to the source. The EGC is connected to the equipment grounding terminals of electrical equipment and receptacles. The size of the EGC is determined by the size of the circuit conductors, as specified in NEC Table 250.122. In the case of an underground service, it is essential to understand the specific requirements for grounding and bonding. NEC Section 250.24 FIV addresses the grounding requirements for separately derived systems. A separately derived system is an electrical system that is not directly connected to the utility power supply, such as a generator or a transformer. When a separately derived system is installed, it must be grounded in accordance with the requirements of NEC Section 250.30. This includes providing a grounding electrode conductor and bonding the neutral conductor to the grounding electrode. For an underground service, the grounding electrode is typically a ground rod or a ground plate that is buried in the earth. The grounding electrode conductor must be sized in accordance with NEC Table 250.66, based on the size of the service entrance conductors. It is important to note that the grounding electrode conductor must be connected to the neutral conductor at the service entrance and not at any other point in the electrical system. This is to ensure that the grounding electrode conductor provides a low impedance path for fault currents back to the source. The neutral conductor must also be bonded to the metal enclosure of the service equipment. This bonding is typically accomplished by connecting a bonding jumper from the neutral busbar to the metal enclosure. The size of the bonding jumper must be sized in accordance with NEC Table 250.102, based on the size of the service entrance conductors. In addition to the grounding electrode conductor and the bonding jumper, it is also important to ensure that all metallic parts of the electrical system are properly bonded together. This includes bonding metal conduits, metal enclosures, and equipment grounding terminals. Bonding is typically accomplished by using bonding jumpers or bonding screws. The size of the bonding jumpers must be sized in accordance with NEC Table 250.102, based on the size of the circuit conductors. It is also important to ensure that all electrical equipment is properly grounded. This includes connecting the equipment grounding terminals of electrical equipment and receptacles to the equipment grounding conductor. The equipment grounding conductor must be sized in accordance with NEC Table 250.122, based on the size of the circuit conductors. By following these guidelines, it is possible to ensure that an underground service is properly grounded and bonded, which helps to protect people and equipment from electrical shock and fire hazards. In the described scenario, the utility provides a 240 volts underground service to a pedestal with a meter and a 200 amps disconnect. The utility has installed a ground rod and bonded the ground to the neutral connection. At the house location, there is a 200 amps panel with a main breaker. The question revolves around whether a 4-wire system is required from the meter disconnect to the panel, and if so, whether the ground and neutral can be bonded at the 200 amps panel. According to NEC section 250.24b, for separately derived systems, a 4-wire feeder is indeed required from the meter disconnect to the panel. This is because the neutral conductor must be isolated from the grounding conductors beyond the service disconnecting means. The neutral and grounding conductors can only be bonded at the service entrance, which in this case is at the pedestal where the meter and 200 amps disconnect are located. The answer clearly states that the grounding electrode conductor must be bonded to the neutral at the service entrance, not at the 200 amps panel at the house. The reason is to maintain the low impedance path for fault currents to return to the source. Bonding the ground and neutral at the 200 amps panel would compromise the effectiveness of the grounding electrode conductor in providing that low impedance path. Therefore, the correct configuration is to have a 4-wire feeder from the meter disconnect to the 200 amps panel, with the ground and neutral bonded only at the meter disconnect location. This ensures that the grounding system functions properly and provides adequate protection against electrical shock and fire hazards. The importance of proper grounding and bonding cannot be overstated. It is a critical safety measure that helps to protect people and equipment from the dangers of electricity. By following the guidelines of the NEC and ensuring that the electrical system is properly grounded and bonded, it is possible to minimize the risk of electrical accidents and create a safer environment.